Welcome to the Lesson 24 activities for Math 107, College Algebra. We're going to write each of the following polynomials in completely factored form. So each of these comes with some suggestions on how to proceed. This first one, f of x equals x squared plus 81, says obtain the zeros by solving for x. So it says start by finding the zeros by solving for x. So zeros are what you get when you solve the function equal to 0. So we have x squared equals negative 81, square root both sides, which means that x equals plus or minus, the square root of 81 is 9, but it's negative, so we've got 9i. So the degree of this polynomial is 2, which means that there are 2 zeros, right? We found them, 2 zeros and 2 linear factors. So if I want to write this in completely factored form, that's always going to be x minus a 0, x minus the other 0. My zeros are 9i and negative 9i. And then instead of minus and negative, I might combine those and write plus 9i. Okay, so for this next one, we want to start by using the quadratic formula to find the zeros. Once you know the zeros, you know the factors, so that you can write it in factored form. All right, so the degree of this polynomial is 2. That's the highest power on the x, which means that there are 2 linear factors and 2 zeros. So I'm just going to start out by writing sort of the format of my answer. The leading coefficient is a 2, and then you're going to have x minus the first 0 and x minus the second 0. Now I just have to figure out what those 2 zeros are, and I'll be done. Okay, so I'm going to find them by using the quadratic formula. I'm going to set my function equal to 0 and solve by using the quadratic formula. So x is the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. Simplify. So I've got 8 plus or minus 9 times 4 is 36, times 2 is 72, so 64 minus 72 is negative 12 over 4. So this is 8 plus or minus, let's see, I'm going to pull the negative out and make it an I. I'm going to pull out the square root of 4 and make it a 2. That leaves me with 3 over 4. Okay, almost there. I just realized I made a little mistake. 64 minus 72 is negative 8, not negative 12. So fix that. And then when we simplify the radical negative 8, we're still going to simplify it to 4 times 2 and pull the 4 out and the negative out, and then we have root 2 there. And then finally, my last simplification here is to simplify my fractions. 8 over 4 is 2, plus or minus 2 over 4 is a half. 1/2 I root 2. So those are my 2 zeros. I go back and plug them into my function that I wrote out here. 2 times x minus 2 plus 1/2 I root 2. And then x minus 2 minus 1/2 I root 2. Okay, part C. H of x is a cubic polynomial. The highest degree on x is a 3. Third degree polynomial, which means it has 3 linear factors and 3 zeros. It says find one zero graphically. We've been given a graph, and then we use long division and the quadratic formula to find the other 2 zeros. So my first 0 right here looks like it's at 1, 2, 3, 4, negative 4. So it looks like x equals negative 4 is a 0, which is equivalent to saying x plus 4 is a factor. So to find the other zeros, we have to divide my function h of x cubed plus 0x squared minus 3x plus 52. Divide that by x plus 4, and we should get a quadratic that we can then find the zeros of by using the quadratic formula. So what do you multiply x by to make x cubed? X squared. X squared times x is x cubed. X squared times 4 is 4x squared, and we subtract. X cubed minus x cubed, that cancels. 0x squared minus 4x squared is negative 4x squared. Bring down the minus 3x and start again. What do you multiply x by to make negative 4x squared? Negative 4x. Negative 4x times x is negative 4x squared. Negative 4x times 4 is negative 16x, and then you subtract that whole thing. Those cancel, and then you have negative 3x minus negative 16x, so it's plus 16x. So that comes out to 13x. Bring down the 52. What do you multiply x by to make 13x? 13. 13 times x is 13x. 13 times 4 is 52. Subtract, and you get 0. No remainder. Okay, so to find my other two zeros, I already know x plus 4 is a factor. You want to find my other two factors by either factoring x squared plus minus 4x plus 13 directly or using the quadratic formula. So I might just start a new blank page here. I'm running out of space. X squared minus 4x plus 13 equals 0. I want to find the zeros of this. So I'll use a quadratic formula. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. 4 plus or minus 16 minus 52 is negative 36 all over 2. So that's 4 plus or minus 6i over 2, which is 2 plus or minus 3i. So there's my other two zeros. So I had one already. I knew x equals negative 4 was a 0, and then I have two more zeros here. So my function, which was called h of x, it's always going to be x minus each of its zeros. Because it's a third degree, it's going to have 3 of them. And its zeros are negative 4 and 2 plus 3i and 2 minus 3i. And then maybe this minus negative 4 thing, maybe we'll change that to plus 4. Just make it a little simpler. So there's h of x written in completely factored form. Okay, k of x, we have another cubic, x cubed minus 5x squared plus 17x minus 13. Find one zero using the table, then use long division in the quadratic formula like we just did in the last problem. So highest power on x is a 3, which means that there are 3 zeros and 3 linear factors, which means that I should be able to write my function k of x with my leading coefficient, in this case is just a 1. So 1 times x minus a 0, x minus another 0, x minus a third 0. One of these zeros I can figure out from this table. What x value makes y 0? That would be x equals 1. So I have x minus 1 is my first factor. And then I want to find my other two factors. I'm going to need to do the polynomial long division. So if x minus 1 is a factor, then that means it should divide evenly into my polynomial, x cubed minus 5x squared plus 17x minus 13. Okay, so we work our way through this. We look at the x and the x cubed. What do you multiply x by to make x cubed? Well, x squared. And then distribute your x squared to your x minus 1. X squared times x is x cubed. X squared times negative 1 is negative x squared. And then you subtract that whole thing. So x cubed minus x cubed cancels. Negative 5x squared minus negative x squared. So that's negative 5x squared plus x squared, which is negative 4x squared. Bring down the 17x. And then ask yourself, what should you multiply x by to make negative 4x squared? Negative 4x. Distribute your negative 4x to your x minus 1. So we have negative 4x squared plus 4x and subtract. Those cancel. 17x minus 4x is 13x. Bring down the negative 13. Start again. What do you multiply x by, this x, to make 13x? 13. 13 times x is 13x. 13 times negative 1 is negative 13. Subtract, and you get 0. So x squared minus 4x plus 13 is the quadratic piece of my factoring. If I want to factor that further, I would use the quadratic formula to see where it equals 0. So x squared minus 4x plus 13. I actually just did that in my previous one here, and it factored to, what was it? 2 plus or minus 3i. So just jot that down what I'm doing. So I'm setting x squared minus 4x plus 13 equal to 0, quadratic formula, and you get x equals 2 plus or minus 3i. So those are your zeros. So we have x minus 1 and then x minus 2 plus 3i and x minus 2 minus 3i. There we go, completely factored form. All right, give an equation with real coefficients of a function with the listed properties. Give your answer in both factored form and standard polynomial form. So I will do both of those forms for this first one, and then after that, I'm going to leave the multiplying it out to you, just to save us a little bit of time here. All right, so quartic means degree 4, right? Which means it's going to have 4 zeros and 4 linear factors. It's got a leading coefficient of 2. So let's see, it's going to be y equals, my leading coefficient is 2, and then it's because it's degree 4, it's going to be x minus, x minus, x minus, x minus. And then I put the 4 zeros in those empty spots there. They gave me 3 zeros. We have one at 1, one at 3, and one at 1 plus 2i. The fourth one we can figure out based on the fact that 1 plus 2i is a 0, because complex zeros always occur in conjugate pairs. It actually is 1 plus or minus 2i. So my other 0 is 1 minus 2i, and that's what goes there. This is the factored form, right? So this is the completely factored form of the polynomial that they were asking for. So that's the first one. And then if I multiply these all together, I would get the standard polynomial form. So let's see what happens. It's going to take me a little bit of work to multiply these all together. Save the 2 outside. My first step, I'm going to multiply x minus 1 times x minus 3. That's just a simple distributing or foiling process. Okay, so x times x is x squared. Minus 3x minus x is minus 4x. Negative 1 times negative 3 is plus 3. All right, and then my next two factors, first I'm going to distribute this negative and this negative. So I have x minus 1 minus 2i times x minus 1 plus 2i. All right, my next step, I'm going to multiply this times this. Okay, it's just a long distribution process. So the way you distribute when you have more than 2 terms in each parenthesis is to start with this x. You start with the first term in the first parenthesis, distribute it to every term in the second parenthesis. Then once that's done, you move to the -1 and distribute that to every term in the second parenthesis. And then you move to the -2i and do that one. So let's see, if I start with my x and distribute to every term in the second parenthesis, I have x times x is x squared, x times -1 is -x, and x times 2i is plus 2ix. And then I'm going to move to this -1 and distribute that to every term in the second parenthesis. So I have -1 times x, that's -x. -1 times -1 is plus 1. And -1 times 2i is minus 2i. Finally, I'm going to work with this -2i and distribute that to every term in the second parentheses. So I have -2i times x is -2ix. -2i times -1 is plus 2i. And -2i times positive 2i is -4i squared. And then I didn't do anything to this parentheses. I'm just going to leave that as x squared minus 4x plus 3 and the 2. Okay. And then this should have all parentheses around it. Okay, my next line. Keeping the 2, keeping the x squared minus 4x plus 3. I'm just going to simplify what's written in green here. You'll notice a lot of stuff cancels. So I have a positive 2ix and a minus 2ix. I have a minus 2i and a plus 2i. And then my minus 4i squared, I squared is really -1. So that's -4 times -1, which is really plus 4. Now I'm going to collect my like terms. So I've got an x squared. For x terms, I have -x, and that's it. So that's -2x. And then collect my constants. So I have a plus 1 and a plus 4, and that's it. So that's plus 5. All right, now I'm going to have to do my distributing of this parenthesis to this parenthesis. I'm just going to keep my 2 carried along for now. And I do the same process I just did. So I'm going to start with this x squared term and distribute it to every term in this second set of parentheses over here. So x squared times x squared is x to the 4th. X squared times -2x is -2x cubed. And x squared times 5 is 5x squared. Moving on to the -4x, distribute that to everything else. -4x cubed plus 8x squared minus 20x, and then move to the 3. I have plus 3x squared minus 6x plus 15. Combine like terms in the parenthesis, and I have x to the 4th. There's an x cubed, there's an x cubed, and that's it for x cubes. That's -6x cubed. And then for x squareds, I've got 5 of them, 8 of them, and 3 of them. So that's 16x squareds. And then for x's, I have -20 minus 6 is -26. And for constants, I have just the plus 15. Lastly, distribute that too. 2x to the 4th minus 12x cubed plus 32x squared minus 52x plus 30. Okay, now we have a quintic, which means degree 5, which means it's going to have 5 zeros and 5 linear factors. It's got a -1 with multiplicity 3, 3 plus I, and a y-intercept of 2. So this time they did not tell me the leading coefficient. They did last time. They gave me this 2 here, right? So they didn't tell me this time. So I think they're going to make me figure it out. So I'm going to start by writing out y equals leading coefficient a, I don't know. And then x plus 1 should be a factor 3 times, because -1 is a 0 3 times. And then x minus 3 plus I. And then just like in the last one, that means I also know another 0, 3 minus I. And a y-intercept of 2 means that if I plug in 0 for x, I would get 2 for y, and that will help me solve for a. So let's go ahead and do that. If I put in 0 for x, I have a times 1 cubed times, if I put in 0 for x, I have -3 minus I. 0 for x, -3 plus I. So I put in zeros for all my x's, and that should give me a 2 for y. And now the only unknown in here is the a, and I can solve for it. So this is 2 equals 1 cubed is 1 times a is a. And then when you FOIL -3 minus I times -3 plus I, you get 9 minus 3i plus 3i, so those cancel, minus I squared. But I squared is really -1, so this says 2 is equal to a times 9 plus 1, which is 10, which means that a is 2/10 or 1/5. So in factored form, my function is y equals 1/5 times x plus 1 cubed times x minus 3 plus I times x minus 3 minus I. And that is my completely factored form. And I'm not going to do all the multiplying out. I'll leave that to the listener to practice out on your own. All right, last one, quartic. That means degree 4. They've given me 3 zeros, but secretly 4 because the complex one has a hidden pair, and then a point. Just so this is very similar to the last problem, except that instead of giving the y-intercept, they gave a different point. So again, they didn't tell me the leading coefficient, so I've got an a there. It's quartic, which means degree 4, so it's going to be x minus, x minus, x minus, and x minus. And then I fill in the zeros that I know. I've got a 0 at -2, 2, I. And if I is a 0, then so is -I. So -I. Quick simplify here, and I get a times x plus 2, x minus 2, x minus I, x plus I. And then to figure out the a, I use the point they gave me. The f of 3 is -150. So if I can plug a 3 in for all my x's, my y should be -150. So I'm replacing all my x's with a 3. So I have a 5. Then 3 minus 2 is 1. And then 3 minus I and 3 plus I. So let's see, I have a times 5. I'm not going to write the 1 because multiplying by 1 doesn't do anything. And then 3 minus I times 3 plus I is, we just did it a couple minutes ago, 10. Oh, that was -3 minus I, -3 plus I. Okay, I'll do it out again. So I have 9. And then plus 3i minus 3i, those cancel, minus I squared. But I squared is really -1, so that is 10. So I have a times 5 times 10 equals -150. Divide both sides by 50, and I get a is -3. It's really tempting to circle that and move on, but that's not the answer. Remember, you have to go back to your original formula and replace the a with the value. So we have y equals -3 times x plus 2 times x minus 2 times x minus I times x plus I. And that is your completely factored form for the polynomial. The multiplied out version or standard polynomial form is just what you get if you multiply those 4 factors together. And again, I will leave that to you.